In this video, I will demonstrate how to do a test of significance and a confidence interval using the four-step method. The New York Times is a large newspaper that is available both in the traditional print format and online. It is known that the mean age of readers of the print edition is 42 years. Age has a standard deviation of sigma equals 12 years. A random sample of 25 online readers had a sample mean age of 35.32 years. Is the mean age of readers in the online version of the Times less than 42 years? Assume that the age of online readers follows a normal distribution. Step 1 of the four-step process is state. We want to state the practical question that we're trying to answer. So in this case, they kind of come right out and tell us what the question is. We want to know, is the mean age of readers in the online version less than 42 years? So I'll write that out again. Is the mean age of an online Times reader less than 42? Step 2 of the four-step process is plan. The first thing that we do in the plan step is identify our population parameter, which in this case is mu. So mu is the population mean, and for this problem, mu represents the mean age of an online Times reader. So mu equals the mean age of an online Times reader. The second thing that we do in the plan step for a test of significance is write our hypotheses. So we're going to have a null hypothesis and an alternative hypothesis. Our hypotheses are always written about the population parameter, so they're both going to be about mu in this case. And typically I like to write the alternative hypothesis first because the alternative hypothesis is really just your practical question that's been written in symbols rather than in words. So our practical question says, is the mean age of an online Times reader less than 42? So if I write that symbolically, that's going to be mu less than 42. The null hypothesis, once you've written the alternative, then the null hypothesis is easy because the null hypothesis always has the equal sign in it. So my null hypothesis is going to be mu equal to 42. Once I have my hypotheses, then I'm going to gather all the important information from the sample. So for this problem, I need to know what x bar, sigma, and n are in order to complete the problem. So reading in the problem, I can see that my sample mean was 35.32, and sigma, it told us, was 12. And in this unit, they'll always tell you what sigma is. And n, my sample size, was 25. All right, so now I've got all the important information. I've written my hypotheses. I'm ready to move on to the next step, which is solve. So step 3 is solve. First thing that we do under the solve step is check our conditions. And there's 3 conditions for this, in this type of, this procedure that we're doing, the one sample Z procedures where sigma is known. First condition is that we have a simple random sample. I don't know, my little pen here keeps drawing strange lines in places. To figure out if we have a simple random sample, we read the problem, and it says that we have a random sample up there in our problem, random sample, so we can consider that condition met. The second condition is that our population is normally distributed, and we can sometimes read the problem. It might tell us there, and if they give us the data, we could go ahead and do a histogram or a stem and leaf plot and check to see if our sample is normally distributed. If the sample is normally distributed, then the population would also be normally distributed. In this case, they don't give us the data, but they do tell us that we have a normal distribution, so check. And then the last condition, this is that training wheels condition that we talked about, which is going to be here for chapters 16 and 17, but then after the next test, then it goes away. And that is that we know sigma, but we don't know mu. So sigma is known. And yep, they told us sigma, so we meet that condition as well. So now we're ready to go ahead and calculate our test statistic. So carry on to the next page here. So the name of our test statistic is z, and z is going to be equal to x bar minus mu naught divided by sigma over square root of n. So using the numbers that we found on the previous page, we can go ahead and fill in all the values for that. So we're going to have 35.32, that was our sample mean, minus 42, okay, and that 42 just comes from the null hypothesis. This is what we're saying mu is equal to under the null hypothesis. So we'll have 35.32 minus 42 divided by sigma, which was 12, over square root of 25. So if I do the calculations on that, I end up with negative 2.78. So negative 2.78 is the value of my test statistic. All right, so now I have my test statistic. I'm going to use that to help me find my p-value. So to do that, I go to table A and I look up negative 2.78. So here's table A, here's negative 2.7, and I'm looking in the 08 column, so I want to see where those two intersect, and it looks like it's right here. So the value from table A corresponding to a z of negative 2.78 is 0.0027. So table A said 0.0027. Now when I get the value from table A, the first thing I want to ask is this the tail area? The tail area is the area that is away from the center or away from the mean. And I know by looking at the value from the table whether or not it's a tail area. If the area from the table is less than 50%, then it's a tail area, and if it's greater than 50%, then it's not a tail area. So in this case, my value was 0.0027. That's less than 0.5 or 50%. So yes, this is a tail area. Then I have to look at my alternative hypothesis and decide if I have a one-sided or a two-sided test. So looking back up here, I can look at this alternative hypothesis and I can see that it is a one-sided test. I can tell that by looking at the symbol that we have here. If it's greater than or less than, it's going to be one-sided. If it's not equals to, it's two-sided. If we have a one-sided test, then the p-value is equal to the tail area. So one-sided p-value equals the tail area, and remember we just determined that that value from the table was the tail area. So we end up with a p-value of 0.0027. If this would have been a two-sided test, then we double the tail area. All right, so I have my p-value here, and all I have left is to draw conclusions. So step 4 is conclude, and our conclusion is going to have two parts. In the first part, we're either going to reject or fail to reject the null hypothesis. And then in the second part, we'll state our conclusions concerning the alternative. So I decide whether or not to reject or fail to reject based on my p-value. And we often compare the p-value to an alpha level. Alpha is called our significance level. And if the p-value is less than alpha, meaning the p is low, then HO must go and we would reject the null hypothesis. If the p-value was high, higher than alpha, then we would keep the guy, or in other words, fail to reject the null hypothesis. In this case, my p-value of 0.0027, that's really small, definitely lower than alpha. So p is low, HO must go. So first part of my conclusion is we reject H naught. Okay, if we reject H0, that means that we have sufficient evidence that the alternative hypothesis is true. So looking back at my alternative hypothesis over here, my alternative hypothesis was that the mean age of an online time leader is was less than 42. So I'm just going to basically rewrite that. So we reject H0 and conclude that the mean age of an online Times reader is less than 42. All right, so now we know that the mean age is less than 42. The next logical question would be, well, what is the mean age of an online Times reader? And to answer that question, we would do a confidence interval. So here's the same scenario, but this time we want to construct a 95% confidence interval for the mean age of online Times readers. So still following the 4-step process, my first step is state. When we're looking at the practical question for a confidence interval, that practical question always starts with what is. We're basically saying what is the mean, only we're going to use a few more details to actually explain what the mean is. So it starts with what is, and in this case we want to know what is the mean age of an online Times reader. So what is the mean age of an online Times reader? That probably should be capitalized. All right, step 2 is plan. First thing we do under the plan step is identify our population parameter, which is mu. So mu is the same as it was in the last problem. It still represents the mean age of an online Times reader. So mean age of an online Times reader. All right, so we don't have any hypotheses because we're talking about a confidence interval, but we do need to know how confident we want to be. And going along with the confidence level, we're going to need to know a z star in order to construct our interval, in addition to knowing x bar, sigma, and n. So looking back in the problem, I can find the answer to most of these here. So we want to be 95% confident, and it tells us that x bar is 35.32, tells us that sigma is 12, and n was 25. So all I need to figure out is this z star. And there's a really easy way to figure out z star if you look at table C. And table C, you can look at the column for how confident you want to be and see where that intersects with our z star row. So 95% confident, z star row, that gives me a z star of 1.96. So back here I'll just write that down. I have a z star of 1.96. All right, step 3, solve. First thing we do under the solve step is check our conditions. Now this is the same exact data that we were dealing with in the previous problem, so we've already checked these conditions. If this was a brand new problem, then we would need to go through the whole process. But since it's a continuation, I'm just going to say check, done that already. So then we can go ahead and construct our interval. So our interval is going to be x bar plus and minus z star times sigma over square root of n. So if I plug in everything that I know here, I'm going to have 35.32 plus and minus 1.96 times 12 over square root of 25. So I'm going to work on the right side of the equation first. That's called my margin of error. So I have 35.32 plus and minus. Now I'm going to take that 1.96, multiply it by 12, and then divide by the square root of 25. When I do that, I get 4.704. So 4.704 is my margin of error. Now I take that 35.32 minus 4.704, which gives me 30.616. And then I'm going to take 35.32 plus 4.704, which gives me 40.024. So that would be my confidence interval. So all I have left is step number 4, which is conclusion. Write the conclusion. Conclude. And there's kind of a very specific way that you want to write your conclusions for confidence intervals to make sure that you don't say anything incorrect. For beginning statistics students, it's easy to throw words in that to you might sound good, but actually make your conclusion incorrect. So I recommend kind of following this pattern whenever you're writing your conclusion for confidence intervals until you really understand what a confidence interval is and what it describes, just to avoid getting points taken off for writing the wrong thing. So we would say we are 95% confident that, and I'm going to talk about the mean. So I'm just taking what I said mu is equal to under step 2, and I'm going to write that in right here. So we're 95% confident that the mean age of an online Times reader, so the mean age of an online Times reader, and then is between, and I'm going to give the bounds of my confidence interval. So is between 30.616 and 40.024 years.